All right, I want to do a few application problems from section 7.2 with you. So the first one I'm going to do involves bearings. So does the second one. We first looked at these bearings in section 5.8. All right, so here we have two ships. They're going to leave the harbor at the same time, traveling at different bearings and at different speeds. And our job is going to be to find out how far apart they're going to be after 3 hours. All right, so let's see. One travels on a bearing of south, 12 degrees west. So we're going to head south. We're going to veer to the west, 12 degrees. So this would be east, west, north, south. And remember, you always veer off of that north-south line. Okay, so the S meant we're going to go down 12 degrees west means this is 12 right here. Okay. All right, and then it says the other travels north 75 degrees east, and they travel at 10 miles per hour. So first, let me just get the direction they're going to be going. So we're going to head north from here, and we're going to veer 75 degrees east. So the angle is going to be pretty big. So this angle is going to be 75 degrees. Okay, so that's the other one. Okay, now this one's going at a speed of 10 miles per hour, and the other guy was going 14 miles per hour. So let me just put those on there so I can see it. All right, so let's think about this then. They're going to travel. They left at the same time, and they're going to travel for 3 hours. We want to find out then how far apart they're going to be after 3 hours. All right, so let's just think about that. So if this guy goes at 10 miles per hour, okay, let me chunk it up into hours. So maybe that's boom, boom. Okay, so he'll cover maybe that much ground. I'm just redrawing my arrow a little bit longer. Okay, so maybe he'll go that far. And actually, let me erase that 10 miles per hour, because then in 3 hours, he would have gone 10 here, 10 here, 10 here, right? So that would be 30, okay? Now, after 3 hours, the other guy's going to have gone 14 times 3, so that would be 30, 42. So that needs to show up to be a little bit longer. Just want the arrow off the end. Let's continue that. Okay, and we've got to imagine something where he goes 42, so a little bit longer than the other guy. Okay. And let me erase just the 14. That's 14 every hour, right? So that means altogether, okay, he traveled 42. Okay, that's 14 times 3. And then the 30 came from taking the 10 times 3. Okay. All right, so we've got this guy being here after 3 hours. We've got this ship being here after 3 hours, and our job is to find out how far apart they are. So that's this right here. We want to know this length, okay? All right, so you can guess it's going to be law of cosines because it's in that unit, but I want you to think about what we need. We need the measure of this angle right here, the angle between those two ships, okay? So to do that, we're going to make use of the fact we know this one's 75. So that means this little guy right here would be just 15 degrees, because the 75 and that 15 would have to make that 90-degree angle. Okay, and then we know this is 90 right here, and then we already have the little 12, the extra amount that we need right there. So that angle that we're needing, let me call it angle A. Angle A would have to be the 15 plus the 90 plus the 12, and that would give us 117 angle right there, okay? All right, so now you're going to make use of that information to find this side over here. I'm going to call it little a. All right, so let's get it set up. Get my elbow to work. All right, so we have that the little a squared would have to equal the b squared plus the c squared. It doesn't matter which one you're calling what. So 30 squared plus 42 squared minus 2 times the 30 times the 42 times the cosine of 117 degrees. Okay, so I'm going to take a moment and type all of that in. So I'm going to do 30 squared plus 42 squared minus 2 times 30 times 42 times the cosine of 117. Make sure you're in degree mode. And you get a rather large number at this point, and you don't want to round off too much yet. Okay. I'll keep it to the nearest hundredth for now. All right, and then I need to do the square root of that, and I'm actually kept all the extra decimals on my calculator screen. I did square root of that answer, and I wound up with A being about 61.709, etc. Okay, and it said round to the nearest tenth, so I'll round it to 61.7. And then this was miles per hour, so that should be 61.7 miles. Okay, so that's how far apart those two ships would be. Okay. All right, so I think bearings can be difficult, so I thought we'd look at another one. All right, and what I want you to imagine here is that we have some islands at these locations, and we're trying to travel between the islands. So if I'm on island A, I want to try to set a bearing for how to navigate to get to island C. Okay, so if I'm going from A to C, you want to think about your origin being at A. Okay, so you want to start there. So what you're needing to know is this angle. Okay, my battery's getting low. Let me take a moment to plug it in. Okay. All right, so we already know a lot about the bearing just looking at it. We know we need to go north some amount and then to the east. So we just need to know what the angle is that I marked right there. So if we find this angle within the triangle, then the one I really need is just the complement of that. It's just the little piece that would add up to be 90 degrees. So what we're going to do is find what I marked in blue, angle A of the triangle, okay? So of course we're going to use law of cosines for that. So we know that the little a squared would have to equal the other two sides squared and added together, minus 2 times 5 times 6 times the cosine of angle A. Okay, so we have 49, 25 plus 36 minus 60 cosine A. And that's 50, that's 61 right there. And then don't try to subtract those. Okay, let's get the cosine A on a side by itself. I'm going to go ahead. I think people do a lot better when the thing you're trying to solve for is on the left. All right, so I'm going to go ahead and do that. So this would be 61 minus 60 cosine A equaling 49. So I didn't really do anything there other than just switch the two sides. All right, and I'm just going to move this down. We'll do that later. All right, so what we want to do is take away the 61. So we get negative 60 cosine A equals a negative 212. Okay, but when we divide by the negative 60, we're going to have a positive number at that point. We'll have cosine A equals 12 divided by 60 Oh, let's see, I know that. That's going to be 1/5, so that'll be 0.2. All right, so I need to do the inverse cosine, don't I, of 0.2. And that gives me that A is about 78. And let's see. I'm seeing what I should round to. I guess it'd be okay to round just to the nearest degree. We've been doing that. It was like 78.46. So it's about 78 degrees. Okay. All right, so now I need to go look. This is 78 degrees. So for the angle we need, I'm going to take 90 minus that 78. That's going to give me 12 degrees. So that needs to be my bearing. Okay. All right, and so then the other question I wanted you, go ahead and be thinking about this one. Pause the video and try it. So what about, let me just write it without the question. What about the bearing from, let's do the bearing from B to C. Let's do the bearing from B to C. Okay. B to C. So let me go to a green marker. Okay, bearing from B to C. So pause the video if you want and work the problem, and then you can kind of check it. So from B to C means I do my starting grid with B being the origin. Okay, so what I'm going to be wanting is, let me erase the island so you don't see that. Okay, so what I'm going to be wanting in my answer will be this angle, but what I'm going to be able to find using the law of cosines is that angle. Okay. All right, so we're going to do the 5 on a side by itself, right? So 5 squared equals the 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of angle B. Okay, so at any point you might want to switch those two sides. And that's really just depends on how good you are with manipulating algebraic expressions. Okay, so maybe right now might be a good time to do it. Okay, so if I take away the 85, I'll have a negative 60. Let me move up a little bit here. And then if I divide by negative 84, I get about 0.7143. It's not my answer. Remember, that's the cosine of the angle. So now I know B would be the inverse cosine of that. So I'm going to go back up, do inverse cosine of 0.7143, and I get that angle B would be about 44 degrees. Okay. All right, so let's bring that 44 up into the picture. That's in here. This is B. And so these two angles together have to be 90. So take away the 44, and you wind up having 46 degrees. Okay. All right, so that gives us the bearing would have to be north 46 degrees, but see how you'd have to veer a little to the west. North 46 degrees west, where the other one was north 12 degrees east. This is B to C. Write that better. This is from island B to C. This is from A to C. Okay. All right. I'm going to do one more application that's not a bearing problem. All right. Sometimes, well, surveyors a lot of times use plenty of trig in doing their work. So here we have a situation where a surveyor knows the angle C, knows it's 80 degrees. They've sighted to spot A and determined the length of that is 65. They've sighted to point B and they know the length from C to B is 105. And so they've been able to determine this information. Our job is to get the distance from A to B. So A is actually this spot right here. And we want to know the length of this. That's like little c. Okay. So that's a pretty direct use of the law of cosine. So we're going to come in here and say that c squared has to equal 65 squared plus 105 squared minus 2 times each of those cosine of 80 degrees. I'm going to type all of that in one step. I'm just going to try to watch myself as I type it in. Okay, double check what you're typing in. Make sure you're in degree mode. And I get 12,879. I'm going to keep a little bit here until after I do the square root. And I actually do second function and my minus sign to pull up the whole answer, so I really don't have to drop any of the digits. And now I get that C is about 113.49. They probably want it rounded to the nearest tenth, I would guess, so that'd be about 113.5. Let me see what they wanted that rounded to. They said to the nearest, no, that was, yeah, to the nearest yard, I think. Yeah. So if we round it to the nearest yard, now this is kind of tricky. Let me show you what it really was. It was 113.4887. So if they're rounding to the nearest yard, it's a 4 following it. So it'd be 113 yards. Okay. Now, if I had done my rounding to the nearest tenth and then rounded again, you might think, oh, well, that's a 5. So that could go either up or down. What do I do? So you really had to look at the original and not round to the nearest tenth first. So it's 113 yards. Okay, and that's what they wanted. That would be your answer. So I just wanted to share a couple of application problems from the law of cosines. You'll see some in your homework. Hopefully that'll help you. And I know bearing problems can sometimes be a bit tricky. Okay, go ahead and number these. Okay.